Okay, welcome back. This is the accompanying video to adding and subtracting, final boss level, introduction to vectors and vector addition. We will be going over vector addition next time. I gave over some basics of it just to review really quickly what was on the other stuff. Vectors are magnitude and direction. We use arrows to know which direction and the magnitude. There are two ways that you can express these vectors. Once again, I need to clarify. I think on my last video I had 60 degrees here, and clarification, it should be 53 degrees. Change that, everything's all fine. You can either express this in how far you have to move in a certain x direction, or how far you have to move in a certain y direction. But you can also express it just in terms of how far you're moving and then where that is relative to the 0-degree axis on a unit circle. We also discussed why there are two ways, even with a map. You could say, hey, I want to go how far in a certain direction, but you could also express how far you have to move laterally and up and down. Also gave an introduction to vector addition, but today, excuse me, let me clear my throat. Just had something to drink. So we're going to talk about how to go from polar to rectangular. So once again, polar is when you are given a certain magnitude and a certain direction, and how you can get this and convert it into this. And then we'll go over, once you have this, how you can convert it back, just to show a kind of proof that that's what you're doing here. So let's say that we have a vector. Now I want to be kind of clear because this is kind of confusing because we've always used v for velocity. V for velocity. V just stands for, we do vectors, it just stands for a generic vector. So I'm going to choose to call this vector A, and so all my work is going to have, instead of v of x, it'll have a of x and a of y and a for there, and a cosine theta, a sine theta. But I have vector A here. So vector A is this green arrow, and you can see that it is in the third quadrant here. I'm saying that it's 10 meters long and it's at 200 degrees. So meaning this is 90, this is 180, and then 20 more would be 200 degrees right there. Hold on here, just this here. Okay, okay. And we want to split it up into its components because we're trying to convert it into rectangular, meaning we're trying to figure out how far do you have to move sideways and how far do you move up and down. So we can discuss another video where these equations are derived from, but basically they're derived from SOHCAHTOA and sine, cosine, and tangent. So components are parts of that. So we're trying to split it up into its parts. Its x component is how far it moves sideways, and its y component. If we can just draw it here and see visually, we have to move to the left, so we should expect our x component is going to be negative because we have to move in the negative direction. And we also have to move down, so we should expect our y to be negative as well. So that's our prediction for that, just based on there. And so I'm going to go ahead and show the calculation. I've already done this forward, just going a little faster. So when we do a of x, so once again, this is the magnitude, this is direction, okay? 10 cosine 200, okay, I get negative 9.40 meters. That makes sense because this is negative, which means it's left, and that is left. And the lozenge here. And then also I did this one. This is 10 sine of 200, try to color code it. And I solved for that one, and that one also is negative, meaning that in the y direction it's down, so that makes sense. Also, it makes sense if you look, even though this is just a rough drawing here, you can see that the red arrow has a longer arrow. It's bigger magnitude than the blue one, and that makes sense over here. This 9.40 is a bigger number than 3.42, so it's looking good so far. Now, you could keep it there, but we like to write it in its final rectangular form. And to remind you what rectangular form is, once again, if I go back to here, that's where you express what the vector is in the x direction, x hat. This just means in the x direction. It doesn't mean x is a variable. It's just a shorthand for saying in the x direction or on the x plane. And then how far you're going in the y direction. So we're just basically just plugging it in here and saying that A equals negative 9.40 meters x hat, And I like to, even though this is a negative here, I like to put plus signs in here and leave the negatives inside the parentheses. It's much easier to search in there. And then negative 3.42 meters y hat. And there you are. You're done. It's just basically saying that this needs to be moving left, which makes sense here, so that's good. And this needs to be moving down, which it is here, and that makes sense as well. Okay. The next thing we're looking at is how do we convert back? Now, if we convert this back to polar form, yes, we should get 10 meters at 200 degrees. That's the obvious point here, but I'm not just going to write 10 meters at 200 degrees. I need to kind of prove that that's what we're doing. Now, if you realize what we have in what this represents here, it represents basically a triangle where this is one leg, this is another leg. And if we were thinking about how would we figure out what A is here, kind of working backwards, well, we should be able to use the Pythagorean theorem to figure out what that was. If I go back to yesterday's notes real quick, and why we can't just add the negative 9.4 or negative 3.42 is that they're not in the same direction. But because we split the two numbers into how far you're moving right or left and how far you're moving up and down, we can create a triangle, and we can use the Pythagorean theorem. So that's basically what we're doing. So here's, here's the equations over here. So don't worry about this. I'll go over in a second. So to find the magnitude, this is the Pythagorean theorem. I take my x component and square it. That's basically my one leg, and I square it. I take my y component and I square it, and I take the square root of that. It's basically rewritten a squared plus b squared equals c squared, but we solve for our vector. In this case, we'll solve for a. And then to solve for the angle, we use the inverse tangent. That should be on your calculator. It should be mode. If you have a TI 80, something like that, and you use Vy over Vx. Now, there is something we are going to have to look at, which is the last sort of key, and it's called, let me see where we are on time. We're doing excellent time. We have to look at what are eventually called angle corrections, and I'll get to that at the end of the video. Let's go ahead and show this calculation here. So I'm going to go ahead and start with the same vector, okay? Just not color-coded, same vectors up there. This is a of x, this is a of y, and I'm going to plug the x component and square it, and then plug the y component and square it. Be careful, we talked about this, if you don't use parentheses when you square a negative in your calculator, it'll give you a negative number. So one way to eliminate this is that if you know this number is supposed to be positive, just drop the negative, okay? But if you don't feel comfortable doing that, then just make sure you do parentheses. So when you calculate that, I'm not just, I did calculate it. You get 10.001, whatever like that, because it's rounded here. But it comes out as 10 meters. Okay, there's a magnitude. Makes sense, right? That's what we had at the top. Now let's see if we can do the angle here. We should do the inverse tangent of our y component over here, negative 3.42 over our x component. And we should get 200 degrees. Oh, however, when we calculate this, we get 19.99 degrees. Something is off here. Now, I can go over this a little bit more, but when you start converting from rectangular to polar, it's always important to do what is called a prediction. And how I'll do it in class is basically how the prediction goes. Is that we look here, and even though we know where this should be, just for new one, okay, this represents our unit circle. I need to move left, and I need to move down, and I know left and down is somewhere here in the third quadrant. So I'm going to use a solid line. Doesn't have to be exact. Doesn't have to. You're just representing it's there, and that is called the prediction. Okay, that's what we know we should get an answer here. However, in this one we get 19.99. That means the calculator is telling us not the third quadrant, but if this is 0, 90, 180, 270, it's telling us here, and I like to put a dotted line here just to represent. That's what the calculator is giving us. So how do we fix this? Because this isn't the right answer. This 19.99 isn't the right answer. And you're saying, why would the calculator do that? Well, one simple explanation is that the calculator can only give you values in the first quadrant or the fourth. Look here. Negative x and negative y, or negative y, negative x, okay? Both of those should give you left and down. It should give you the third quadrant over here. But if you think about it, the calculator sees these two negatives, and just like you would in any other math, you would cancel those two negatives out. However, those negatives mean a direction. So if the calculator just cancels those negatives out, it sees it as a positive y, up, and a positive x, right, which is the first quadrant. It can also happen where, you want to be in the second quadrant, and it gives you in the fourth quadrant. So there's a pretty easy way. You have to memorize some things here. There's three scenarios. So let me try to move my camera down further here. There's three scenarios for what are called angle corrections. So this is very key because if you put 19.99 degrees there, it's wrong. You're going to get marked off. Angle correction if necessary. Okay. So how do you even know if you have to do an angle correction? I kind of did this up here and color coded it. This, my prediction here, and basically it's what here, my prediction is that it should have been in the third quadrant, and the calculator is saying it should be somewhere else. At that point, you're realizing this is not the same. I need to do an angle correction. So you'll have to eventually memorize these, okay? There's only three scenarios. If it's not one of these scenarios, you do nothing. You just leave it as it is, okay? The first scenario is if it's in the second quadrant, and the calculator gives it in the, basically if they're in opposite quadrants, either opposite, sorry with shadows here, opposite this way or opposite this way, if they're ever, you just add 180 degrees, okay? Okay, you add 180 degrees. For example, if it gave you here, it might give you, we don't like to use negative degrees, so let's say you had, this was negative 60, okay, and then it says to add 180 degrees, negative 60 plus 180, it would give you 120, because that's what we actually want. We don't want negative 60, we want 120, okay? So that's not our scenario. Doesn't match there. Let's look at the second scenario. It says it should be in the third quadrant. The calculator is putting it in the first quadrant. That's a similar thing. It's an opposite quadrants here, and so you'd add 180. And so that's what I did here. I added 180, and yes, it comes out to 199.99, but for the sake of this here, it comes out to 200 degrees, which is what it should come up here anyway, and we had to do that. The last scenario is to avoid us using negative degrees here, okay? So if your prediction should be in the fourth quadrant and the calculator also says it's in the fourth quadrant, okay, then you add 360. We're just basically saying instead of having negative 60 here, if we add 360, we're wanting to know what is this angle. And that angle right there is not negative 60. That angle right there is 300. Okay, so negative 60, that is 300. If it's any other scenario, you do nothing. Basically, the only other scenario you could have is that if you predict it's in the first quadrant and the calculator says it's in the first quadrant, do nothing. Okay? So instead of memorizing all the times you have to do nothing, just memorize the 3 times you have to do something. So opposite quadrants, anytime, add 180. Same quadrant in the fourth, only in the fourth quadrant here, then you add 360. Now, I want to just one last time, how do you know? You have to do a prediction. Whenever you're going from rectangular to polar, you have to do a prediction of which way it is going to go. So give me a second. Let me grab a worksheet real quick. So I can explain the worksheet that I put up on Schoology. Okay, we're going to be eventually working on that Monday and Tuesday in class. We can certainly get ahead of time and then have some time off. So in this worksheet, once again, I'm not a French teacher, so I like to put some different things. I made an example here. So this is the front side. This is where you are converting into the components, okay? So this is basically this part here. So it says 145, N stands for Newton, not north. You convert it. Now I didn't have enough space here. You'd ultimately want to write it as A equals negative 37.53 newtons x hat plus negative 140.06 newtons y hat. So obviously I already have my work there. I would make it a little more concise. So that you'd write that would be your final answer. So that's the front side. That's all you're doing there. There are some ones that are, let's see here. I think I got rid of the 0 ones. Okay. And I do have the answers. The other side is the really important side, and what I mean angle correction. So I did the first one here, and it's giving me K. It says negative in the x direction. So negative in the x direction means left, and positive in the y direction means up. And so if you look closely here, and I just tried to model what that looks like here, I made a, let me go ahead and focus that, sorry. I made, so negative, left and up means that my prediction should be in the second quadrant, so that's my firm line, that's what it should be. After doing some calculations here, I got my magnitude, which is good. I did the inverse tangent of all those, and it gave me negative 73.29. If we think about, 0, 0, 90, 180, 270 positive this way, negative 73.2 is in the fourth quadrant. So that's why I put the dotted line. And then I go, hey, what do I do? What scenario is it of all these? Is it the scenario where they're in opposite quadrants like that? Well, I can add 180, basically add like that. And for this case, it ends up being the first one, okay? I mean, these are basically the same. You just, if they're in opposite quadrant, add 180. So I went over here and I added 180 degrees and I got 106.71. And that makes sense because in this, so I'm getting something that's like that. I don't want negative 73.29. I want to know what is that angle, and that is 106.71. So you won't always have to do angle corrections, okay? It's only if it's one of these three scenarios here. So it's only if these three scenarios, okay? I think that's going to go ahead and wrap that up. I will have the answers. If it's not already up there, I can't remember if I left it on there. So we're going to be having a very short quiz on likely Wednesday now, maybe or Tuesday, but likely Wednesday. All it is I'm going to basically give the class two of these, two problems, something like this. They have to convert back into polar, angle correction, and two of these where you have polar and you have to go into rectangle. So that's all it is. So if you can work on that at home, ask questions if you need it. Feel free. So that wraps up how to convert from polar to rectangular and rectangular to polar. So I appreciate you watching. Please keep in contact and stay up on Schoology.